Wood plastic composites, or WPC technology, is a very fast-growing sector of the plastics industry. And the technology can be either a one-step or a two-step process. In the one-step process, we compound the wood and the plastic to make the composite, and this is extruded from the extruder to make products such as decking or flooring or fencing, that sort of thing, all in line in one step. Now the other way of doing this process is to have two steps, where the first step is the compounding step, where we mix the wood and the polymer, the plastic, and we pelletize it, and we can keep that pellets, and we use that in the second stage later, where we can use it for making the decking or even injection molding. Now, this line I'll be demonstrating today is the two-step process in which we will be making the WPC pellets. So this is the line. We're using a 26mm twin screw extruder, 52 L/D, which is quite long, and we have the plastic which goes into this hopper, fed into the feed area here, and around here we have three side feeders, 1, 2, and 3. The first two are for feeding in the wood fiber or the wood flour, and these are fed in using gravimetric feeders, this one for that side feeder and this one for this side feeder. So we split the wood maybe 20%, 20%. And this third side, well, it's a side feeder unit, but in fact this is used for removing volatiles or steam from the product, because wood is very hygroscopic, meaning that it absorbs moisture. And this means that before we can use the wood flour, we have to dry the wood. Typically it's about 8 or 10%, but we have to dry it to about 1 or 2%. But there's always a little bit of moisture left in the wood, so as the material passes down here, it's heated to around about 180 or 190, depending on the polymer, and any steam or any volatiles will be sucked out of here. We have a suction unit here. Here's the valve for the suction and the vacuum gauge, and we can see what's going on by looking in there, and we can clamp that tight. So what this does, we have a very high-speed screw in here, which is preventing the melt from coming out of the barrel into the side feeder. But there's enough space to allow any steam or volatiles to come back, and it gets sucked down here. And we have a vacuum suction unit inside here. So this is only for removing any remaining steam from the WPC melt. So these are gravimetric feeders. We also have a gravimetric feeder for the main polymer feed, which is here. So we have 3 gravimetric feeders, one here, and one here. And these are controlled using this control panel. So this is the control panel for the loss in weight or gravimetric feeders. As you can see, there are 6 gravimetric feeders, so this single control unit can control 6 separate feeders. This is for feeder number 1. You can see these are kind of identical. Number 1, number 2, number 3, 4, 5, and 6. And the color shown here inside, yellow, means that it's set on gravimetric mode, but not running. When it is running, these will change to green. And the height of these, the level gives an indication of how much material is in the hopper. So this one is about 2/3 full of material, this similarly here, but there's only a small amount in here. And we've inputted here, to begin with, 10 kilograms per hour. We can start operating at that feed rate and then increase it later on. We can actually we can start and stop the individual gravimetric feeders using these buttons here, run and stop. So that's the control for the gravimetric feeders. So here we have the control panel for the extruder. First of all, you can see here this heat symbol in green means that the heats have been turned on for the extruder, for the barrel. We can set the temperatures down here. This is the set value and this is the actual process value. So the temperatures here have been set 180 at the upper end, increasing to about 210 and then dropping down to 190 and then finally 185. It's important not to run the extruder at too high a temperature because wood flour actually starts degrading at 190 degrees C. So it doesn't want to be much over 190 degrees. The extruder will be running fairly fast, so we can afford to have a slightly higher temperature because the residence time will be short. These values here, 207, 211, 210, these are monitoring the temperature of the melt at every second barrel section. So 2, 4, 6, 8, 10, and also at the die. This gives the pressure of the melt at the die. Over here, these are the 3 side feeders, 1, 2, and 3. By pressing that, we can hear one of the side feeders is working. Press again to turn it off. And we can change the screw speeds or the feed rate of either of these gravimetric side feeders by increase, decrease, number 2, increase, decrease, number 3, increase, decrease. And on the right side of the screen, we have on-off for the vacuum pump, and also for the suction here. Down here is the setting for the screw speeds of the extruder. Scroll up or scroll down. We can input the password from here. And on the left side of the touch screen, we have the controls for the pelletizer. You can see the lock on here, which means that it's not on. And we can change the pelletizer speed by scrolling up or scrolling down. At the moment, it's set at 38 meters per minute. And we can set the length of the pellets on here. Scroll up or scroll down. This is, so we can go make a longer length or shorter length. 3 millimeters is the standard pellet length. So there are all the controls. That's a description of the control panel for the extruder. This is the power on and off, reset button, and in emergencies, emergency stop. This will shut down the whole line by pressing that. So if we look down towards the downstream here, this is the die. It's a 4-strand die, as you can see. So the molten material will come out of there in strands, come into the water bath, get cooled in the water bath, and they'll go under these guide rollers and come out here. This is a nylon brush, which will remove any droplets of water that are attached to the strands, get rid of most of the water, and vacuum is applied here, vacuum suction. So the strands will pass through these slots in here, and this will remove any remaining water from the surface of the strands. And after that, the strands will go to the pelletizer. But you'll see here, this is the control panel for the water bath. And this is the switch. This is showing that it's set to manual control of the water bath, or we can turn it to auto, which means we can control it using that touch screen over there. So in this case, we can't use these start and stop buttons, but if we turn this to manual, then we can start the vacuum. So this is vacuum on and off, and this is for draining of the water from the overflow of the water bath. And finally we have the pelletizer. So the strands come over here, go through and the pellets will pass over here onto this stationary cutting blade. This rotates at high speed, so this chops the strands into pellets which drop down here and into a container. And again, this unit can be controlled either manually or automatically. So on manual, we can see the rotary cutting blades going around. But when we turn this on to auto, we can control it using the touch screen over there. So in this case, this is inactive. So that's the line. And we have a unit at the back here, which is for the barrel. This contains demineralized water, and this is used for operating the solenoid valves and for cooling the barrel sections, so that we have very good temperature control. So we're just starting up now, and we will just run the polymer first before we start introducing the wood flour. So you can see from this control panel that this is turned green, which means that it's running under gravimetric mode, and these are yellow, which means that these are gravimetric mode but not running at the moment. And over here we've just started the screw at 101 RPM. These are green, which means that the side feeders are running. And if you look at the die, you'll see the pure polymer coming out. So here you see the polymer coming out, pure polymer. There's no wood being added to the polymer at this stage. We'll just string up the line, make sure it's running nice and stable. Then we can start introducing the wood flour. So the pure polymer is coming out of the die now. We'll just make a clean cut across the die, feed the strands under the guide roll in the water bath, slowly pass it under the other guide rolls, and through the nylon brush, which removes these droplets. You can see on the strands we have droplets of water. That will remove most of those, and the strands go through these slots, which has vacuum pulling any moisture away from the strands, so that when the strands go into the pelletizer, they're all completely dry, nice and dry. You can see droplets of water dropping off the nylon brush from time to time. So now that the pure polymer is coming through and it's being pelletized nicely, we can start adding the wood flour. So we've gone to hopper number 3, and he's pressed run. Go back to the home screen and you can see it's green now. which means that it's running in gravimetric mode. The cooling water actually is not very cold, which is good, because it means that when the strands come out of the water bath, they're not very cold, they're still quite warm, and that will help to remove any traces of moisture that are left on the strand. And being warm strands, it means that they're relatively soft, so it's even easier to pelletize the strands. So we certainly don't need a chiller. This is quite warm water. So here the dry strands after the suction section here, these are nice and dry, being fed into the pelletizer, being chopped by the rotary cutters and dropping down into this container. Let's see, all nicely dry now. And still quite a nice light brown color, which is what they should be if there's no degradation of the wood.